Thank you, Stefan, and thank you for the invitation. It's my pleasure to be with you today. I'm Nicolas Clerk. I'm a strategy manager at Caterpillar. The work I'm going to share with you today is related to my previous job as an economist at Caterpillar. So I will try that laser.
There you go. Excellent.
Works. Cool. A little bit of forward-looking statement from the lawyers. We are asked to incorporate that into our presentation and a brief presentation of Caterpillar. So been in business since 1925, supporting customers around the world, developing the infrastructure, product that build and expand the Panama Canal, for example, or construct parts like the Golden Gate Bridge. Today, we help customers develop infrastructure and natural resource assets around the world. In 2019, we had sales and revenues of close to 54 billion. And we have 21 brands in our product and service portfolio. Based on that, Caterpillar is the world's leading manufacturer of construction and mining equipment, diesel and natural gas engines, industrial gas turbines, and diesel electric locomotives. Customers can count on 165 Cat dealers present in more than 191 countries. So the key question is, how do you get the right product to the customer at the right time, given that it takes time to procure the material, manufacture and ship some of these products around the world for the customers to have the right product at the right time. And briefly, it all starts with the demand planning. So we start with the customer. And starting with the right, you see everything. Spend a little bit of time doing animations, but it's lost in the upload, so bear with me. At the top here, we have the customer. Again, because it takes time to produce and ship the product, we can't wait for the customer order. So we have to start manufacturing. So we have to anticipate those sales to end users. We call it sales to end users because Cat would produce, sell to a dealer, and the dealer would sell to the end user. So STU, or sales to end user, is something or a term that we'll use in this presentation. So we start by the first step in the demand planning. So anticipate the sales to end user. Then we monitor the inventory that dealers are maintaining. And for some products, they have, think of the smaller end or smaller pieces of equipment we do carry, or dealers do carry in an inventory. For some of the largest mining equipment, is really made to order. So based on this expected demand and what the dealers could absorb through the inventory, we have a commercial shipment. So the shipment between Cat and the dealer forecast. Based on this, we can move to the sourcing and production planning step. Will be done at one of the Caterpillar plants around the world. And then based on what we can produce, so what we expect to demand, what we can produce, we have a supply planning going the other way around. When we can ship that equipment to the dealer, when it will hit the dealer inventory, and when the dealer will be able to bring the key, that new piece of equipment, to the customer. So this is really a simplified view, but it gives you some of the my laser. Now, this is really a high view of a sales and operation planning process, but this is where we applied this Bayesian network. So how do you forecast sales to users? This is a key question, and a simplified view, again, here to illustrate. This is a scatter plot of the year-over-year growth rates of the US economy captured by the gross domestic product in real term. So inflation is out. We see that sometimes we have contraction in the US economy. That was the 2009 recession. We have about a 2.2% growth on average here. And that's the break even for the person or growth in the durable manufacturing of the manufacturing of durable goods, including IT equipment. So right here, we see that there is something cyclical. When the economy is growing, time for me to turn my laser on again. Sorry. When the economy is growing, meaning we are to the right here, that 2% threshold, see that we tend to see more sales of durable manufactured goods customers. And a truck or an excavator or an engine would fall in that category of durable manufacturing. Not the only one, but again, this is publicly available data, and so this is a good way to illustrate. When we have the economy slowing down, so still growing between 0 and 2%, but this is below the potential growth for the US economy, then we tend to see a slowdown in investment. When the economy is really in recession, sharper contraction. The R square is pretty good. Again, we tend to see those business cycles continuing, even though every time we go through a crisis and out of the crisis, you might hear people say, oh, we learned and it will never happen again. It does. We have business cycles and see them going away. So we got the economy growth at the bottom here that drives the demand for capital goods. Fine. How do we then go up that chain and understand what's driving this investment? And I would classify the economic drivers that drive the investment into 3 buckets. First one is confidence, business confidence. The second one is the activity. The third one is financing. If you have a very highly confident customer for whom the activity is really booming, and he or she can finance the expansion of the machine fleet, then we're likely to see the investment happening. If we're missing any of these buckets or we see weakness developing, then the case for investment might be in between. Might still happen, but it won't be as strong. You could have the most confident customer seeing the really booming activity. If that customer cannot bring the financing together for whatever reason, then the investment might be delayed. So for each of these buckets, we have a long series, and I'm just listing a few here to illustrate, a long series of potential indicators. Purchasing Manager Index, for example, or in Europe, we have the Commission running surveys about business confidence, are really good proxies of that confidence. For the activity, we have all sorts of measurement of the activity. I talked about the gross domestic product, that's one, but we also have industrial production measures. We have housing construction. We have commodity prices as an activity, a measure of demand and supply balance for mining. The list here is really quite long. And on the financing side, we do track central banks' monetary policy, where their reaction function, what they want to achieve in the short, medium, and longer term. We do track interest. We have lending standards on surveys of lending standards from banks that are run around the world, credit activity, corporate profits, because you can finance the purchase of these pieces of equipment through internal retained profits. So again, the list is very long, but there are common themes, and I try to classify here for the sake of time. So Caterpillar has a team of economists since the mid-50s. And the economists since then did about the same job of trying to help our internal business partners to prepare and best anticipate for the customer demands and changes in the market conditions. So the economists do the variable selection, which variables are important and which are not. In many instances, I found myself in a meeting and people just read the Financial Times or Wall Street Journal or any economic newspaper and would start a discussion by making a statement or asking a question. And newspapers are not in the same business as corporate economists. We don't need to sell papers, but we need to sort through what is important to us and what is not. That's a key function. But we also look at the joint and conditional probability distribution, these variables, and the target. We prepare forecast both of the planetary variables of the nodes, if you want, but also of the target. And we infer the consistent target forecast. So it sounds very Bayesian in a sense. Then comes more of the communication. So how do we communicate the work we're doing and the expectations in simple terms to our business partners? They are not all fond of monetary policy or joint probability distribution. So how do we translate that, help them grow the business? Do that for all the products. So machines, construction machines, mining machinery, engines, in all regions over all forecast horizon. And we try to be as consistent as possible all the time. So over the 70 years that we had economists, we had different characters. And how do you bring the same quality of forecast to the business partners over time as people rotate in the group? So again, I had a not so elaborated nation, but it was bringing some questions around variable selection. Did we miss anything? Over the past 70 years, we had time to test assumption and look over time what worked best. So we think we understand what are the key drivers, but again, did we miss anything? Are there new data that are available today that were not today, or which we don't have maybe enough of that history to judge their usefulness? We think we, again, understand how those variables play together, but think we got it right. But there is still again, doubting is always a good thing approach to forecasting. We do prepare a variable forecast. We are geared toward point forecast. So in the sales and operation planning process that I described earlier, the forecast would be captured as we expect sell X number trucks of that size, that region in that month. And very easy then to prepare for it, but it's masking some of the uncertainty. Sometimes we feel stronger about a forecast. Sometimes we feel the distribution is wider. There is no really way in the sales and operation planning process system they capture this. It is all qualitatively assessed through the series of meetings that we have all along the steps I described. Bias and precision are always key concerns when we do target forecasting. Communication, again, we talk in plain, simple English. That's what drove the forecast or the assumptions. underpinning this forecast. But being able to show the reasoning might be a plus in certain situations. And we do this for all products all around the world. So a form of industrialization to alleviate the economist of repeating the mental process or the explanation in a series of meetings could be useful. And the repeatability is, again, tying back to the consistency. Just a quick on our BayesiaLab journey. It all started by a colleague when I was based in Peoria, Illinois, telling me, I know someone you should meet. They do cool stuff, and that might be of interest to you. And that someone was Stefan. And the colleague met him in Nashville and started to look at the BayesiaLab website and placed a cold call to Stefan to meet and go through, hey, tell me what you're doing. Indeed, interesting. So we had a few meetings here to describe what BayesiaLab is for, what you can do with BayesiaLab, how it can help through all the questions that we now downloaded and dive into the. Actually, I bought a printed version of the BayesiaLab book and started to learn more about BayesiaLab, starting to think through what we would want to do with it. Then we had a series of proof of concept with Stefan to de-risk the building blocks. Can you build a time series forecast? Can you, again, depending on your application, wanted to, for our application, be sure that we could do what we want to do for buying the license. Did? And then went through the two series of BayesiaLab courses, so the introductory and advanced. That was intense, but absolutely necessary, in my opinion, to know what to do. And then we developed a high-level prototype just to put together the different building blocks that we de-risk early in the process, and then spent 2 days in Laval. I was based in Geneva by then. Days to complete the prototype. Then it went into testing, and that was a long journey, but again, learning so much along the way and finding this concept from an idea down to something that is. So the first step was, and you recognize the visual on the left, we replicate the economist knowledge in BayesiaLab. And in that sense, that was a very close spirit to what the L'Oreal team just described, is how can you bring experts and replicate their knowledge. One approach is through Wiki. The second one is through data mining. So what we have on the left is I would dub the economist ESCM, or a structural equation model, because we have, through training and tribal knowledge that has been transmitted between economists over the years, build a ESCM. We have a hierarchy of, okay, this is happening, this is going to influence or impact the investment here or the purchase decision of our customers in such and such way. We threw in the long list of all the drivers and actually build a ESCM in BayesiaLab. So the answer is yes, we can replicate a ESCM or a hierarchy of vast number of economic drivers to a series of unobserved factors into a condensed version of the economic environment. So at the center here, you would have a summary of what the state of all these economic variables that we have here on the outer ring would mean. And the second portion was to bring it or connect it to what we have to do, meaning forecasting the industry and the sales to users. So this is a demonstration model for today, but this is not what we have in production. It is simplified in some sense of bringing different parts together. So let me describe it. Starting from the left, we have that hierarchy of hidden factors, if you want, ESCM, that connects some economic goals, the left, through the three factors here. And this is driving or determining the industry growth year over year. With the industry growth year over year and the industry in T-1, we can forecast the industry at time T. This is the total industry because those economic drivers will determine if we need to move dirt to build houses or bridges or roads here, but it won't tell if it's Caterpillar piece of equipment that is going to move that dirt or if it's a piece of equipment from the competition. So this is really the economy here driving the demand for moving dirt that is addressed by the machine fleet or machine industry on the ground. Then we have percent of industry sales here. This is really, like the term is telling, the percent of industry sales that is coming to Caterpillar. And so the industry times the percent of industry sales gives our Caterpillar sales to users. I've summarized here one note through the marketing effort. So if we have the percent of industry sales in T-1 and we do such marketing efforts, we can expect that percent of industry sales. Then we have function nodes that would extract the sales to user growth and the pain scales. So this is really a summarized model of what the economists are doing. They are consuming a history of economic variables, forming expectations about those economic variables that would then influence the industry growth and the industry we can expect. Then working with our business partners about the marketing efforts, also what we get as signals from all the connected assets that we have around the world. What signals does it gives us about how hard the elite is used, happening in terms of conditions on these machines. Informs us about percent of industry sales and sales. Now that we have this model in place, we could play with these monitors. And here I'm just showing three for a simulation product here, simulation industry. So I have the three factors. So we have the three colors for the financing condition, variable 1 here. And I'm expecting this average, this expected value for this particular financing condition in year T. For the confidence, I have this expectation that is variable, and for the activity, I'm expecting all the other ones are left as the median, but I could condition on all of them. And as I'm doing this, I'm saying the probability distribution that the machine industry evolving. So here, based on if this happens, it means that my probability distribution has this dispersion and this expected value. So it's making the connection very clear between the economic environment and what it means for our industry or our customers. So how we use it today, again, we have an integrated model of economic variables all the way through the machine industry and our sales to end users. It is really used to supplement work that is done on a continuous basis on the sales and operation planning process. So we would sit literally and go through that discussion with the product manager who has to make the final call about how many trucks or excavators or engines is going to build. So we sit and tell the story again in plain English. We expect the economy to recover or to be hit by the COVID disruption. What extent? We show it, we tell the story in plain English, but then we can show it and can hence see the impact and the risk around that point forecast. So we, again, get a point forecast from the sales and operation planning process, but we can put that point forecast in perspective to the probability distribution. So it brings a lot of transparency to the discussion. Our business partners can challenge or run on the fly scenarios. Hey, what is the financing condition or this commodity price would evolve in that way or that way? We can model it again through the monitors and measure the impact on the probability distribution. In the probability, it is widening, it is narrowing those point forecasts. So it brings a lot of transparency and simplicity to very complex discussions. We couldn't illustrate it through the use of those monitors and probability distribution. It is a long journey, I would say, and we continue to build our capabilities and awareness generally. And I see this as a very valuable tool, again, to complement the existing framework that we have, framework from it, but also from a sales and operation planning process perspective, so information content of those discussions. What I wanted to share with you today.